Okay. What we are called another terminology called mini batch. So mini batch. Okay. So you know, in our training process, you suppose you have we usually will feed a lot of training data. For example, 1 million data as your training data. So if you use all the 1 million data and to update, try to use all the data to update your weight metric by using the previous process. Okay, so it will usually take a long time. So they developed another idea called mini batch. Mini batch means I separate the training data into several batches. Like this. For example, I separate the two training data together. So I group the two data together. F1, the first data, and the 31 data, they are together. They form a batch. Then another, the second and the 16. Okay, you can organize such a batch by yourself or by just random choose. And then so you, for example, here you form a two batch. Right? Each batch they have different here is a different data in each batch. And first, okay, we apply the same algorithm again. First, we randomly initialize your initial configuration, is 0. Okay. Then we pick the first one batch, this one. Then we use this first one batch to calculate the total cost by using all the data in the first batch. And then we use the gradient to update experiment at the theta 1. Okay. Then next we take the second batch. Here we take the training data in the second batch. We can see to count the total cost here, and then calculate. Apply the same gradient descent to calculate its parameter. Here we use the theta 1. You remember theta 1 is update from theta 0 by using the first batch. Then we will use theta 1 again. We will continue use the theta 1 to do the training and then to update it at the theta 2. Okay? Okay? This is okay. And then the next we will go back to the first page. So we go back to the first page. So actually there is a while loop. We go back to the first page to do the same thing again. To update. Now it becomes a theta 2. We will use theta 2 to update it to be the theta 3. And then go back to the second page. We will update theta 3 to be theta 4. And we just repeat all the page several times. Okay? So it's called a one epoch. Each iteration is called a one epoch. In all we say the one iteration. So we will repeat several times until it's converged. So you know you in such optimization, when it's converged, means its error is very stable. If the error is reached, maybe reach a very small, and it will never the error is getting stable, means it's almost unchanged. Okay, so we can say converge. So we can start. The algorithm is called a mini batch. Okay. So let me summarize idea. Mini batch is to divide your training data into several batches. So for each batch, you just take the first batch to update the parameter, then take the second batch to update the parameter, and repeat. For example, if you have 10 batch, you will have to pick 10 batch and we call it one iteration, or called one epoch. And then you see if your error is not converted, okay, so you can continue to do the process again to pick the first one, the second batch, okay, to do the second epoch, okay, or let's say the second iteration, to update the parameter again and again. And its result will generate much better because you don't need to calculate the whole training data in one epoch. Sorry, you don't need to update your parameters by using all the training data. You just use a fraction of your training data and you update your parameters. And then use the update parameter to do the next menu, to use the second batch to update the parameter again. So you don't need to use the 1 minute, all the training data, 1 minute data, because you will spend a lot of time to do the one modification, one process, to do the update. You just need maybe you just take 1,000. 1,000 is in a batch. Suppose if you divide all the data into maybe 100 batch. 100 batch. Each batch will has how many? Maybe 10,000 data. Okay, so each batch has 10,000 data. So for each, you just need to update, use the 10,000 data to update your parameter here, and then use the second batch to update your parameter again and again. And each time you will convert so fast. And this is better. Well, according to the experiment, they say, although such a mini batch will not as better as you use the whole data in your training, but it's very fast. So after several iterations, it achieves the almost identical result as you use the whole data as a training. Okay. So now the standard process is applied the mini batch to do the training. And most of your tools, for example, for the neural net tool, they will apply such a technique automatically to do the mini batch. Or we say the called stochastic gradient descent. Stochastic gradient descent. Okay, so with this idea, so such a technology you will often see in neural net, in deep learning. So now you know the technology, so you will not get confused about it. So mini batch just means I will not use the whole data to update your parameters. No, I will divide the data into several parts. Use the first part to update the data, then to update the parameter, and use the second to continue to update. So you see, so if I divide the data into 4 parts, so when I go through all the training data, I have updated my parameter 4 times, right? But with this, I just update once. It takes no time. Okay, so this result, it can achieve the smallest error, but it takes too long time. This update so fast, and so we can run it several times, more than this one. you can run the process. You can run multiple if up, much more than this. And because it runs so fast. And after several times, you can achieve the same performance with this one. Okay? So it's the power of the mean batch. It's just a tip to accelerate the training process. Right. Okay.真的是分分辨就是10分，把所有资料都在10分里面。然后第一讲在调完之后再把它这个调完之后送到这个。对。那如果它有一个这个资料相似的话，你说每次调的参数很相似吗？比如说像它这边，它这样别的它。我们现在输入了1到20，然后可是如果它需要像这样子的话，比如说我切的时候，它可能前面第一个跟全部都是，然后好像就会有这样的问题。通常是要稍微乱分数，就是要乱一点分数差。对，要乱一点，不要全部都分到第一轮，这样实际上做好这种。它就是变成它这样变成，如果全部都是第一群全部都是数的话，它要对就是对1好。它在决定第二群的数的要决定这个对，就把1块就是比较难，如果比较难调，它最后还是可以调过来，但是要包含这个数列，所以一开始就应该是很乱的，资料就是越来越变成所以有点像是它是会放，反正把所有这个随机的放在这个备选里面。这个100个备选对，多少倍都可以，反正做不到，每次都拿这个备选先去再去另外一个备选，这样子比较快，它一直在更新，在更新上面的参数，很快就可以收敛。那个刚做完这个之后，那如果要再做下一轮，那是要拿上面你最后一点参数去下一轮，还是下一轮就要重新开一个参数？就是一直拿你上一轮嘛，训练好参数，再回到上一次对。就是这一轮全部做完对，比如说你就这个样子，这一个做完好，就得到西塔1嘛，西塔1它就会拿去到西塔2嘛，做完了嘛，好，回到西塔2再给它，因为你要把你训练结果找回这样，这样才会更新嘛。好，这个你用那些工具啊，比如说像是 Google 的训练Pro，或者是别人或者小 B，它可以用这些工具，他们都会弄完这个，然后要下一个参数，你要开始做，它就自动帮你做，自动帮你把你的训练自动帮你自动分类好，看你要做什么，自动帮你做。所以这知道有这样的技术。Okay, you just need to know we have such a kit to accelerate your training process, and it's just a switch provided in many neural tools. You just need to open the switch to say, I want to use this function. I want to divide the data into maybe 1,000 spaces or 100 spaces. Just specify some option. Okay, and all these tools, the library will do it automatically. You don't need to worry about the details. Okay, so it's a basic function in neural. Okay, but you have to know the terminology. Otherwise, you don't know what is this going to do. Then you will not use this function very well. Okay. Any further problem? No? Okay. Okay, so back propagation. So we finished have finished the first propagation to English with the terminology. Okay. Okay, so a network can have millions of parameters. So backpropagation is the way to compute the gradient efficiently. Okay, so many toolkits can compute the gradient automatically. So actually you don't need to derive the first derivation by yourself. No, you don't need to spend the time to do it. All these theorem, TensorFlow, all these they all use they can calculate the gradient correctly. Okay, it's very easy to apply. Just call the function. It will calculate the gradient for you. Okay, so for here, piano is written by Python. You can include the piano library in your Python language. Then you can use Python to write it. And the TensorFlow is also a Python-based language. Okay, so if you know Python, the grammar of the Python, you can do it's very easy for you to use this tool. TensorFlow is supported by Google. Okay, still continually supported by Google. And others, for piano, I would like, because TensorFlow is much higher, it's a higher level, it will provide some higher level user interface. So it will be better for you if you are a newbie in this area. For piano, it's maybe better for experts because there are so many details you have to tune by yourself. But for TensorFlow, it just take many functions together. Okay, you just need to call the function. Okay. Some other tools like Cafe is not further support by the Python, so it's tough to develop. So I would not suggest you to use Cafe, although it's also very popular in one or 2 years ago. But now I think maybe you can use Google TensorFlow. Yeah, it looks like looks very good. Okay. 好，这种工具非常多了 ，so many tools, neural net tools you can use。好，那现在比较知名的是 Google support 的这个 TensorFlow。好，那其他还有一些很小的小工具 ，open source 你都可以去下载到，你都可以找找看。好，那另外有一个叫可贝的本来是那个哪一个大学 Stanford University, they have a team to develop the cafe, but this team is closed, so they don't support to update the cafe anymore. So I think maybe you can. But cafe is very fast because it's written by C++, so it's very fast, faster than using Python, but it's not supported and I think, yeah, it's closed. The team is closed. No more updates. Okay, so I did the part 2. We're talking about why we want to go deep. Okay, the question is why we want a deep neural net, not a fat neural net. Fat means you have many neurons in one hidden layer. Like this, you see? It's fat. You can use more neurons to make it facial. Okay? But we hope deeper. Deeper means we will have many hidden layers. Okay, maybe you can think, how about use the fat? And for this case, I just use 2 layers, 2 hidden layers, and in this hidden layer, I use a very fat, very wide, a lot of neurons. If this performance, maybe the fat is better than the deep. A deep means I use many layers, each layer with a few of the neurons. Which one is better? Okay, this here this part want to discuss this question. Okay, here just show you experimental result. The experiment show you that. Okay, here I use the multiple layer. You see, here is a layer. I use one layer. This layer with 2,000 neurons. Here is the second. We should use the two layers. Okay, 3 layers, 4 layers, 5 layers, and here is the error rate. You see, the error rate is okay. It's very obvious. Yeah, it makes sense. Yeah, it's very trivial because you use more layers. You can lower down the error rate, right? You see, the error rate is getting more. So not enough price, more parameters, better performance. Okay, so which one is better? Use the use the shadow. Here you see the shadow because it's just 2 layers, but it's fake. Or use the deep. You see here it has 3 layers, but each layer just has it's very just 2 neurons. Which one is better? Okay, here show another experiment result. Okay, so here if you use only one hidden layer, you see the performance. Even you use a fake remaining neuron here, you can see even I use 16,000 neurons in one layer, but its error rate is still very high. But how about it? If I use just only 7 layers, each layer is 2,000 neurons, so total neurons will be 14,000. It's still more than this, but the error rate much more than this one. So through the experimental result, you see the deeper is better. Okay. Okay, so the professor also want to use the logic circuit to explain why different. Okay, so okay. Okay, here is the idea. So we can, given you an image, you can feed to 3 different classifiers. Each classifier will give you an answer like this: glow is glasses, or this classifier will tell you maybe a voice with glasses. Classifier 3 tell you voice wears good shirt. Suppose you have 3 different classifiers. But for such a design can be, you can use a multiple layer to do it. For example, first for this is the first layer. You see the first layer, you can see this neuron is used to classify boy or girl, and then feed it to its next layer. And this neuron responsible for classifying with glasses. This neuron is used to classify wearing a blue shirt, like this. And all these features can then fit to your next level, and to generate your final classification result. So we think it's such the design is more simpler. It's very much easier to interpret the result. So here is a comparison between the SVM and deep learning. Okay, I'll compare with the compare with the neural net. So you see, in SVM, our input space like this. So we want to separate the 2 classes, blue one and red one. So you see, we cannot find a linear separator here. So we can use the kernel function to transform all this data to a higher space, higher dimensional space here, and then in this space you can easily find a place to separate the two data, the two groups. Okay? So here is the idea of the SBA. Okay, so for deep learning, we can achieve the same result by using the search of many layers, many hidden layers, and they can form a nonlinear function. So these hidden layers, and then we store these nonlinear. This is actually has the same function as the kernel. You can treat it as a kernel function, a nonlinear kernel function. They do the same thing. So you can finally will generate the result. Storage function, storage hidden layer. It's because the learnable kernel. The kernel is learnable. But for here, in SVM, this kernel is designed by yourself. You have to design it by yourself. But this is deep learning. All these functions, the weight can be tuned, right? You can tune this function through the training. So it's a learnable kernel. So a learnable kernel, you usually can generate a better result. Okay, so there's another machine learning technique called boosting. So boosting is try to give you an input. I will use several weak classifiers, and I will connect all the weak classifiers together to combine them together to generate the final result. Deep learning is also very similar. Okay, you see, each one layer is also a weak classifier. Okay, so you see, then I will combine it together. For this neuron, just combine all the weak neurons together to generate the output, right? And then all these are used as a weak classifier for the next layer. Okay, so it's very similar to the boosting, but it's much power. Yeah, because the boosting you just only one layer, right? Only one layer. Here just have only one layer, then you combine together. But in neural net you have 1, 2, 3. You can decide more and more. Okay. So, and here you see maybe you think the deeper is better, but there's still has this limitation. So if you use much more, for example here, you use 10 layers, the accuracy is down to 50%. You know, for the handwriting classification, a benchmark can reach almost 95 accuracy. Yeah, but we use more layers, it's just down to 50. Okay, so how to leverage the power of deep learning? Okay, so it's here part 3 will tell you some tips how to train a deep neural net better. Okay, we have talked about some tips, for example, the mini batch. Okay, so there are still some tips. Okay, so I think, okay, so time is closed.